That's it.
Right. So I just myself and Connor are here again. We're going to try and I want to show him how rebatment is done in this resource, and we're just going to play the video there. And I want him to look at it, and he can ask me a few questions about it then.
So now I'm set up with one of the sides ready to rotate. I'm going to rotate it up to this point here, and
you
then
see,
to the
just
right
look at
point.
it. See it there in the
view. Look, this is going
top
to be
view.
the exterior.
You see the exterior circle there?
Yeah.
That's where it's going to be lifted up to.
So it's actually going to touch the circle. Or touch
Yeah,
the
yeah.
sphere, yeah.
So we found that already by using that circle
Yeah.
in
Yeah.
the perspective. That's, you can see it touching the.
Oh, that's the point there, yeah.
That's
yeah,
the point
yeah,
of contact there. We found where it's touching the sphere,
yeah.
and we drew an intersection point there for it.
Okay.
Here, we're going to grab this point, end point here. And
Just watch those, it moves up now. You can see the yellow triangle move up, and it comes up. And I had the intersection point
You
in,
can do it again. It'll show it.
Yeah,
so it's showing the rebatment.
exactly, yeah. It's great that you can see it in 4 views as well. Like.
Yeah, it is handy, isn't it?
Very.
So you can like explain.
Yeah. And you're
For teaching, it's very good because you can explain. I know you can set it up in SolidWorks as well. Like
Especially
that.
something like that, something complex like that
is do that on 5 sides
brilliant. Like.
and
Yeah.
repeat it. So that'll be the next video, and I'll show you that then done.
So like in the next part now,
And
instead of
so
having to do that 5
rotate.
times, we've done is you polar array,
And
like mirror
just
entities
select
Yes.
on
that,
SolidWorks.
Yeah.
rotate, get
So
the point
you're just
from
drawing
where
the
you want to
five
start,
points
bring up
around.
where you
Plus as well, what you
Okay.
can do, say if you're
So,
drawing this
thought you know
physically, right? Say if you're drawing that physically, if you have that circle that's out there, right,
Yeah.
in the plan, you know that height, you can get that height through an auxiliary view,
Yeah. Yeah.
right?
Exactly.
Get that height through an auxiliary view, bring that up to your plan, get that height, and then you know that's your angle then back to that you're going to go to.
Exactly. Yeah.
So you're just doing rebatment, but like this is just showing it very easily, and the program is working out easier how to do it, but you're going to have to manually draft it.
Yeah. So this view here, this is our polar array being
Yeah.
worked, isn't it?
Yeah, it is. Yeah, so like,
Okay, so another quick update here is...
so what I did is I copied
I
that,
just reverted here.
The
You
whole
can
way
see
around
the
5.
triangles
Yeah.
in place.
but you have to set it
Ready
for
the
360
next set of
degrees so it'll
triangles to
cover.
go in
Yeah.
fit
And you have to
with
set it
that.
for copy.
I'll show you a trick for that in a minute. This one now shows the...
So once you're
triangles in the
half
top
done,
view.
so
what you do
we're
with
drawing
this one,
an
do it,
icosahedron
so what
here,
you
so
do
I'll just
is
pause that a second. So
across the-
it's an icosahedron, so it's 20-sided
Yeah.
shape, right? Platonic solid. Each of those triangles are equilateral, right?
Okay.
Every one of those triangles meets at the same dihedral angle, right?
Okay.
So no matter where you put the points, it'll always fit into it. They'll always fit
Always
into
fit
it.
into
So
each other, yeah.
basically, once you draw the first the bottom half of that, all you have to do is get another half again and put them
Pop
in,
it on top.
and they fit exactly into each
Yeah.
other. So that's kind of one of the things about platonic solids is they have that symmetry.
Yeah.
And
Yeah.
like
Yeah.
central symmetry comes into this a lot because we were able to put the 5 sides around in the same place. And then we were able to put the other half on top of the other half.
Yeah.
So central symmetry is another big thing in this. You go around, and when you go on to do 4 frequency then as well, you'll go from 1 frequency to 4. And the symmetry then is once you have one triangle worked out from 1
Yeah.
frequency to 4 frequency, you can actually repeat that on the other
Oh, right,
triangles
okay.
then
Okay.
on the top.
So
So
essentially using junior cert graphics, central symmetry
Yeah.
to
and
do
you just
this
make it,
complex.
you find the same point. So like the question I did there from Anderson's book on page 242 was once you had one triangle, say if you're doing the plan and you're trying to get the frequency and extend it out, once you had that done on the one triangle, equilateral triangle on the top, you just had to repeat it then for the other 4. So it's very easy. Yeah. So like even though it's complicated to get to it, once you're at a certain point and you've done it,
Exactly.
it's just repeating it, and then it becomes a tessellation. Do you ever hear
Hard
tessellation?
tessellation, yeah.
Yeah, so it's just a pattern created with polygon shapes in a constant pattern. So
Yeah.
like a geodesic dome, all of those platonic solids are tessellations because they're a constant pattern
Yeah,
of
yeah,
polygons. So like that's what you end up creating
Yeah.
once you have the geodesic done out to 4 frequency and what have you. But we just go on there now to the. So this is
Oh, that's it there. Yeah.
so you go on to that's
your
half.
half, yeah.
I have it
Bottom half
rendered
of the
there a little.
icosahedron, and you can see it's selected there because it's highlighted in yellow. Now I put in this Orient 3 point. I don't know if you
So
can
yeah,
read
there
that
was,
up there.
so basically
So
the
you
Orient
just
3
type
point
it in
was
Orient
once
3
you had
point,
3
and basically
points
what I'm going to
found
do is going
on
to
the
select 3 points
on the bottom half.
Yes. Yeah.
bottom
You
half of
just
the icosahedron. So
reverse
it's
them upside down.
Okay. Yeah.
So you pick
like
them
that.
a certain way.
I know what I need to
upside
do
down,
is put them
on
in
any other part.
upside down.
Look.
So I'm going to go 1,
Just watch it there now a second. You see,
Oh, that's it. Yeah.
Two.
Yeah. Yeah.
and 3 there,
fits it in.
and should be
you have to make sure and copy it though.
enter.
Yeah.
Else
And
you're
now
going to
we've
take the
full
one that you have.
icosahedron there because we've just dropped it upside down, so you can see
Sorry.
it's full there now. Okay, so that was after a couple of practices, of course, because I couldn't be wasting time doing that here. But now you can see you with the full
So
icosahedron
that's basically
there.
what I was trying to do with the
And
resource, but you
you're
can
ready to
see
go.
how you'd learn a few things from it.
Okay,
You know?
Yeah.
thanks very much for that.
Absolutely.
Okay,
That's good.
that's more or less. I went on to do more, but that
So
gives you a
back
good
to there now
understanding
again.
about
I'm just going to
cosahedrons.
repeat
Have
that
you any
because
questions?
for anyone that wants to be able
No,
to
not really. I
do,
think you explained an awful lot there.
um,
Like it's essentially applying these technical graphics style principles to a Leaving Cert DCG room, essentially, or at least Leaving Cert DCG topic. Like.
Yeah, and just adding a bit more, like when it goes on now from this to 4 frequency, you're going to go into spherical geometry. You're going to go into this first and second views of well, you might go into multiple auxiliary views to get points and stuff like that, because you know I use the umbrella analogy for it, and it was like when you open umbrella half, you've the spike, you've the 8 arms sticking out, and they're not stretched. But when they're stretched out fully, they become bent,
Yeah.
and they expand outwards.
Yeah. Yeah.
So when a geodesic dome goes from 1 frequency to 4 frequency, or any frequency above that, it expands 3-dimensionally.
Yeah. Yeah.
You know, it doesn't expand in area.
It doesn't expand
in-
linearly. Yeah.
It
Exactly.
expands in volume as well.
Yeah.
So this is trying to get at that as well. Like,
Yeah.
and, you know, resource then as well as trying to get at that. But thanks very much.
Perfect. Yeah. Thanks, man.